So let's see an inspiring story of Baby Halder. Baby Halder, the maid who became a best-selling author, and her background is she was a child bride at 12, mother of 3 by 20, and worked as a domestic help in Delhi to survive. Abusive marriage, abandoned with the children, cleaned houses during the daytime, raised the kids, and wrote at night time with discarded notebooks. She wrote a book called A Life Less Ordinary, a raw memoir that translated into 20 languages, invited to Global Lit Fest. She didn't have peace, privilege, or polish, just persistence. If she could write her way out of despair, you could code your way out of confusion. ठीक है? ठीक है? Just listen to this story, guys. A lady who works as a maid during the daytime has written a book in the nighttime while managing children, and she became the best-selling author. If she could do it, we could do it. She is an Indian. She is a hero to me. She is a hero to me, and she is a hero to you all. Jai Hind. So let's start context-free languages. Let us say a power m, a power I, c power m, c power k, c power m, d power k, d power k such that m comma n comma I comma k are greater than or equal to 1. M comma n comma I comma k are greater than or equal to 1. M comma n comma I comma k are greater than or equal to 1. Think about it. Take 2 minutes. Think about it. And then you can answer. Take 2 minutes. Think about it. And then you can answer. Think about it. A power m, b power I. After that, c is compared. You may feel that this is not context-free language. One thing is for sure, this is not regular. One thing is for sure that this is not regular. ये बात तो हमको पता है, ठीक है? Now, will it be context-free language? See, A's have to be compared with C's, but then in between there are some number of A's. How are you going to do that? That is the question. If you can do it, you can call it as context-free grammar, context-free language. Can you do it? Think about it. There is a small twist in the question. I'm not going to reveal it right away. You think about it first. You think about it first. So, I will tell you the answer. I can write it as a power m, a power I. I can write it as a power m plus I, c power m, d power k, such that m comma n comma I comma k greater than or equal to 1. Greater than or equal to 1. Right? Now, if you observe it, what does this two mean? This means that number of A's should be greater than number of B's. So, I am going to retry it. Number of A's are greater than number of C's. I am going to rewrite it. Okay. I am going to rewrite it as A power X, B power Y, D power K such that X is greater than Y. That's it. X is greater than Y. Now, there is no need to compare these. You need not do anything with these. Only thing is compare A's and B's and see that compare A's and C's. Here it is C. A power X, C power Y, d power k such that x is greater than y, right? Right? Compare this with C's. Compare A's with C's. Compare A's with C's. So which one is greater? A should be greater, and we have done this model already, right? So if you feel that this is little bit difficult, let us do a small thing. Let us do a simpler question and then get back to this, okay? Let us do a simpler question. If you feel that this is difficult, let's do this. A power m, a power I, b power m such that m comma n greater than or equal to 1. Let's do this, then we will get back to that problem. Now try to do this. You will be able to understand. Let's try to do this, then you will be able to understand. Okay? Let's try to do this and then you will be able to understand. A power m, a power I, b power m such that m comma n greater than or equal to 1. So, how are you going to write this? You can write this as a power m plus I, b power m such that m comma n greater than or equal to 1. Even m comma I is also greater than or equal to 1. Okay. Now if you observe it, I can rewrite this as a power x, b power y such that x is greater than y. And we have done this already. And this is a deterministic context-free language. This is definitely not regular, but this is a deterministic context-free language. Okay. Now you see this. I have added d, just d. It is the same question, right? Just adding d power k. There is no need to compare d power k with anything. So here also x is greater than y. We have done it. This is deterministic context-free language. This is deterministic context-free language. Okay. Okay. Let's do one more question. Let's see one more problem here. A simple one. A power m, b power n such that m is less than n. Right? M is less than n. What can you say about this language? We have already done context-free language PDA for this language. If you remember, we have done PDA, right? So this language is deterministic context-free language. Sometimes they will give it in a different form. They will say a power m, b power I, c power m, a power m, b power m, b power I, b power m, a power m, b power I, b power m, right? They will give it like this. Then what are you going to do? You are going to combine them. A power m plus I, b power m. Now you can easily solve it, right? So I can rewrite it as a power x, b power y. A power x, b power y. A power x, b power y. Right. Now we can clearly see that x is greater than y. X is greater than y. We can clearly see that x is greater than y. Okay. Let's do. Now let's see one more problem. A power n, b power 2n such that n is greater than or equal to 1. We have already done the push down automata for this, and we know that this is deterministic context-free language, and sometimes they can add something extra to this, right? Something extra like a power n, b power 2n, c power m, right? It does not change anything. After comparing a's and b's, you don't have to compare c's. It does not change anything. You have to just see all the C's. Therefore, this one will also be deterministic context-free language. This one will also be deterministic context-free language, DCFL. Okay, okay. Now let us see the next one. Now let us see the next one. A power n b power n square. A power n b power n square. A power n b power n square. A power n b power n square, such that n is greater than or equal to 1. A power n b power n square, such that n is greater than or equal to 1. N is greater than or equal to 1. A power n b power n square, such that n is greater than or equal to 1. Try it. Try doing it. Take a minute of time. I will explain anyway. Try doing it. So if you observe it, this b power n square is not a linear power. It is not linear. What is linear? If I get n, 2n, 3n, this is linear. If I get n square, n cube, n power 4, this is non-linear, right? So whenever you get non-linear, PDA cannot do it. Definitely, finite automata cannot do it. Therefore, it is not regular. And PDA also cannot do it. Therefore, it is not DCFL. It is not DCFL. It is not DCFL, right? And also, it is not CFL. It is not CFL. CFL also cannot do this, right? But this is CSL. CSL will be able to do it. Later, we will see how CSL will be able to do it. Okay, okay, okay. Fine. Now, do this. A power n, b power 2 power n, such that n is greater than or equal to 1. A power n, b power 2 power n, such that n is greater than or equal to 1. A power n, b power 2n, such that n is greater than or equal to n. Again, in this question also, you are going to see non-linear power of 2. Non-linear power, hai na? This is a exponential power. 2 power n is exponential. It is non-linear. So, again, regular cannot do, obviously. And DCFL cannot do. And CFL cannot do. Therefore, it is done by CSL. Later, we will see how CSL is able to do this. Okay. Later, we will see how CSL is able to do this. CSL is able to do this. Okay. Now, W power R such that W belong to A comma B star. W belong to A comma B star. Take time and answer it. Take time and answer it. W power R such that W belong to A comma B star. W power R such that W belong to A comma B star. So what is this language, guys? What is this language? We have already seen it. This is even length palindrome. Even length palindrome. This is even length palindrome. And we cannot find out the center in this. The problem with even length palindrome is that we cannot find out what is the center. Therefore, this is definitely not regular. This is definitely not DCFL. But this is CFL. This is definitely not regular. This is definitely not DCFL, but this is CFL. A CFL can do it. Non-deterministic push-down automata can do it. We have seen it. Non-deterministic push-down automata can do it, and we have seen it. Okay, we have already seen it. Right, 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 right. Now, if I write like this, WC W are such that W belong to A comma B star. WC W power R such that W belong to A comma B star. WC W power R such that W belong to A comma B star. WC W power R such that W belong to A comma B star. WC W power R such that W belong to A comma B star. Okay. Here, what is this? This is a palindrome. This is a palindrome, and here center is known. Center is known. We know the center. This is a palindrome where center is known. I told you that when palindrome is there and center is known, then it can be accepted by DCFL. It is definitely not regular. Regular languages cannot do this, but this can be accepted by DCFL. We have also seen the deterministic push-down automata, right? So this is deterministic context-free language. It is not regular. Okay. Since it is DCFL, this is CFL also. Since this is DCFL, it is CFL also. Okay. Okay. WW such that W belong to A comma B star. WW such that W belong to A comma B star. So this is not WW power R. You may think that context-free languages can do it. Let us take an example. Let us say W equal to AB, right? Then what will be WW? WW will be ABAB. WW will be ABAB. W equal to AB. WW will be ABAB. ABAB. Now, if I push initially A and B onto the stack, A and B onto the stack. Now, if I have to compare A is below B. I cannot compare. I cannot compare this A with this A because A is below B, right? Because A is below B. Therefore, this is not. Therefore, this is not DCFL. Therefore, this is not regular. This is definitely not regular. This is definitely not DCFL. And even CFL cannot do it. Non-deterministic push-down automata also cannot do it. But this can be done by CSL. This can be done by CSL. CSL can do it. Okay. Later when we see Turing machines, I will tell you how CFL can do this. I will tell you how CFL can do this. Okay. I will tell you how CFL can do. Now let's see the next problem. A power n, B power n, C power m. A power n, B power n, C power m. This is nothing special. You are going to compare A's and B's. After that, you are just going to see the C's, right? So this is definitely not regular. This is definitely not regular. This is DCFL. This is definitely DCFL. This is definitely DCFL, right? Right. So here m comma n is greater than or equal to 1. This is definitely DCFL. But here if I do a small change to it, if I say A power n, B power n, C power m such that A power n, B power n, C power m such that m is greater than n, which means here A's and B's have to be compared and then B's and C's have to be compared. Both of them have to be done simultaneously, right? So definitely this is not regular. We know that. Deterministic context-free language also cannot do it. DCFL can also do it. Cannot do it. CFL can also not do it. Therefore, it is CSL. Later, I will show you how it is CSL. Okay, it is CSL. Later, I will show you how it is CSL. How it is CSL. Okay, okay. Now, let us see a different model. A power n, B power n, C power n, D power n such that n is less than or equal to 10 power 10 power 10. Think and answer. Think and answer. think and an answer. Think and answer. ठीक है? Think and answer. So this language looks like it is not context free. This language looks like it is not context free, but the problem is n is less than or equal to 10 power 10 power 10, which means this is a finite language. This is a finite language, and any finite language is regular. This is a finite language, and any finite language is regular. This is a finite language, and any finite language is regular. Regular. Okay. I'll give you one more question. Try to solve this. A power n, b power 2n, c power 3n such that n is greater than or equal to 1. A power n, b power 2n, c power 3n such that n is greater than or equal to 1. Okay. So here what is the problem? A's have to be compared with B's and B's have to be compared with C's, or A's have to be compared with B's and A's have to be compared with C's. Anyway, we need two comparisons in two comparisons at a time. Two comparisons at a time. And CFL cannot do two comparisons at a time. It can do one comparison at a time. It cannot do two comparisons at a time. It cannot do two comparisons at a time. Okay? It cannot do two comparisons at a time. It can do one comparison at a time, but it cannot do two comparisons at a time. It can do one comparison at a time, but it cannot do two comparisons at a time. But it cannot do two comparisons at a time. It can do one comparison at a time, but it cannot do two comparisons at a time. It cannot do two comparisons at a time, right? So one thing is for sure, this is definitely not regular. And second thing is, this is definitely not DCFL. And the third thing is, it is definitely not CFL, but this is CSL, right? But this is CSL. I will show you later why this is CSL. Okay? 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 Let's do one more question. A power n, b power 2n, c power m such that n comma m greater than or n comma m greater than or equal to 1. Such that n comma m greater than or equal to 1. Such that m comma n greater than or equal to 1. Such that m comma n is greater than or equal to 1. Try it for 1 minute. There is no hurry. Try it for 1 minute and tell me. So here, A's and B's have to be compared, right? That can be done by DCFL. DPDA can do that. And C's can be ignored. There is no problem with C's at all. Therefore, this is deterministic context-free language, and definitely this is not regular, right? It is definitely not regular because A's and B's cannot be compared. Infinite comparison with regular languages is not possible, right? So this is DCFL. Since this is DCFL, this is CFL also, and this is CSL also. Okay, this is REC and RE also. We need not write all of them. Okay, we need not write all of them. We need not write all of them. Okay, okay, or do this. A power n, b power 3m, c power 2n such that n comma m greater than or equal to 1. Take time, no urgency. Take time and do this. Take time and do this. Take time and do this. Here, here, A's and C's can be compared, and in between A's and C's, there can be any number of B's, not any number. The number of B should be multiple of 3, right? So what do? You push A first. First you push A, right? And then you check B's are multiple of 3. B's are multiple of 3. And then you pop A's for every C. And then you pop A's for every C. For every C you pop A's, right? Push A's, see that number of B's are multiple of 3's, and then pop A's for every C. And then pop A's for every C. Right? Right? So it can be done. It can be done. Right? Right? Now I'll give you one more question. Try to do this. X, C, X such that X belongs to A comma B star and C is a special symbol. 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 Right? For example, if X equal to AB, if X equal to AB, what will this become? AB, C, AB. It will become AB, C, AB. AB, C, AB. AB, C, AB. Right? It will become AB, C, AB. It will become AB, C, AB. ABCAB. Now the problem is this is definitely not regular because in regular you have to match A with A, B with B. This cannot be done by regular languages because the string may be longer, you may not be able to compare it. Now the question is, can a push down automata do this? Can I push AB onto the stack? Can I push AB onto the stack? And then after seeing a C, can I compare A with this A? It is impossible because A is below B. You cannot compare this A with this A. Therefore, this language is definitely not regular. One thing, this language is definitely not returnistic context free language. This language is definitely not context free language, and this language is not, this language is context sensitive language, right? A Turing machine can do this. A Turing machine can do this. This is definitely context free language, right? So context free languages has linear bounded automata. This is nothing but a Turing machine with linear bounds. I will tell you later, okay? I will talk about context sensitive languages later, okay? 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 Let's do the next question. X, C, Y, X, C, Y such that X comma Y belong to A comma B star. X comma Y belong to A comma B star. X can be anything, Y can be anything, and C is a special symbol. C is a special symbol. C is a special symbol. Here C is a special symbol. Here C is a special symbol. Think about it. Don't try to answer it directly. Just think about it. Whenever I give you a time, take 1 minute of time, think about it, and then do it. Okay, this is an important question. Take 1 minute of time. This is an important question. Take 1 minute of time. Okay, take 1 minute of time and then you do it. Okay. Think about it and do it. Right, right. So this is a simple question if you think about it. X and Y can be anything. So I can write this as A plus B star C A plus B star. Now what did this language become? This language has become set of all strings containing C, isn't it? This language has become set of all strings containing C. Set of all strings containing C. This is set of all strings containing C. 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 Right, right, right. I'll give you one more question. Try to answer this. I'll give you one more question. Try to answer this. X power R such that X belongs to A comma B star and mod X equal to L. Mod X equal to L. Mod X equal to L. Which means this is set of all even length palindromes with a limitation that the length of X is always L. The length of X is always L. The total length is what? 2L. The length of X is always L. Okay, think about it. Think about it for 1 minute and answer me. There is no need of any urgency. Think about it and answer me. Write in the comments. Okay, write your answer in the comments. Write your answer in the comments. Write your answer in the comments. Okay. X power R such that X belongs to A comma B star and mod X equal to L. So here you can easily say that this is a finite language and every finite language is regular. This is a finite language and every finite language is regular. Every finite language is regular. Okay. Okay. Now let us say W power R such that W belong to A comma B star such that W belong to A comma B star. W power R such that W belong to A comma B star. W has to be A comma B star. W such that W belong to A comma B star. Such that W belong to A comma B star. W power R such that W belong to A comma B star. W belong to A comma B star. Okay. So the problem is WWR can be done by a push down automata which is non-deterministic. But the problem is we have to compare W with W. This cannot be done by a push down automata, right? Therefore, this language is clearly not regular. This language is clearly not DCFL. It cannot do it. WW power R cannot be done by DCFL. And this language is not context-free language because WW cannot be done by context-free language. 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 Right? But this can be done by context-sensitive language. I will show you later why it can be done by context-sensitive language. Okay? Okay? Now let us say A power n, B power 3 power n such that n is less than or equal to 10 power 10. A power n, B power 3 power n such that n is less than or equal to 10 power 10. N is less than or equal to 10 power 10. N is less than or equal to 10 power 10. N is less than or equal to 10 power 10. How are you going to do this? N is less than or equal to 10 power 10. How are you going to do this? Think about it. Take time. There is no urgency. Take time. There is no urgency. Think about it. There is no urgency. Think about it. Think about it. There is no urgency. A power n, b power 3n. A power n, b power 3n such that n is less than or equal to 10 power 10. N is less than or equal to 10 power 10. A power n, b power 3n such that n is less than or equal to 10 power 10. Here it is very clear that this is a finite language. This is a finite language and therefore this is regular. You can directly say that this is regular. Okay. Even though the language looks like it is not a context free language, but it is regular. If it is given like this, a power n, b power 3 power n such that n is greater than or equal to 1, then this is infinite language. It is not regular and a DCFL cannot do this and a CFL cannot do this and only CSL can do this. A power n, b power 3n, only CSL can do this. Okay. Only CSL can do this. Right? 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 Now, a power m, b power n such that m is not equal to n. A power m, b power n such that m is not equal to n. A power m, b power n such that m is not equal to n and m comma n are greater than or equal to 1. M comma n are greater than or equal to 1. A power m, b power n such that m is not equal to n and m comma n are greater than or equal to 1 and m comma n are greater than or equal to 1. So what does this mean? Either A's can be greater or B's can be greater, right? Either A's can be greater or B's can be greater. How are you going to do this? You simply push all A's for every A. A on Z0, push A Z0 and for every A you push A. For every A you push A, right? And then when you get a B, you keep popping on A. When you get a B, you keep popping on A. When you get a B, you keep popping on A. Then two things may happen. One thing is A's may be over. In that case, what do you get? B, Z0, leave it as Z0. And what is the other thing may happen? A's may be over. What will happen in that case? If A's are over, then you are going to see Z0, B, Z0, Z0. If A's are over, what are you going to see? If A's are over, here B's are over, here A's are over. Therefore, you are going to see a B and Z0 on top of the stack. Leave it as Z0. Here A's are over. Now what happens if B's are over? So in the top of the stack, epsilon B's are over and top of the stack A's are remaining. Then you are going to accept. You are going to leave it as A. So here just make a check that only B's are there. A's are over. Just see that only B's are there. Okay. So how are you going to see only B's are there? Any number of B's come, leave them as B's and then you continue, right? Any number of b's come, leave them as b's. Any number of b is in the top of the stack, and any number of b's come, leave it as b. Finally, when all the b's are over, epsilon, b will be on top of the stack, z0, b will be on top of the stack, leave it as b, and you accept it, So if a's are over, this is the case. If b's are over, what is the case? 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 If b's are over, input is over, and still a's are remaining. Therefore, you don't have to do anything. Just accept it, right? So this is a deterministic pushdown automata. This is a deterministic pushdown automata. It is comparing whether a's are over or b's are over, right? Which means either a's are not equal to b or b's are not equal to a. Both of them are being compared. Okay, this is a deterministic pushdown automata. Therefore, the language is definitely deterministic context-free language. The language is definitely deterministic context-free language. Deterministic context-free language, right? Now, tell me about this. A power I, b power j, such that I is not equal to 2j plus 1. I is not equal to 2j plus 1. A power I, b power j, such that I is not equal to 2j plus 1. A power I, b power j, such that I is not equal to 2j plus 1. I is not equal to 2j plus 1. So we have already calculated a problem like this, right? So number of i's should be not equal to 2j plus 1, right? So you push all a's, and for every a you push 2 a's, and for every b you pop a, and then one extra b should remain. Therefore, this can be done by deterministic context-free language. This is a deterministic context-free language. This is not regular, right? And so it is context-free language also, and so it is context-sensitive language also. It is recursive and recursively enumerable also. It is recursive and recursively enumerable also. Okay, we will see the next question. Now let's listen to a story. Okay, let's listen to an inspiring story. Pratish Datta, IIT Kharagpur, MSc Mathematics, visually impaired, lost eyesight by college, dependent on his mother for learning early on. MSc in Mathematics from IIT Kharagpur, topped his cohort with a CGPA of 9.87. A person who does not have vision, a person who is blind, topped his cohort with CGPA of 9.87, and he won Professor Jagadish Chandra Bose Memorial Gold Medal. He's a gold medalist, right? A visually impaired person is a gold medalist. See guys, he cannot see, but he got a gold medal. What are you doing? You can see, you have arms, you have legs, you have computer, you have desktop, you have everything that is required. Why are you not able to succeed? See, the impact demonstrated exceptional intellectual resilience, turned his disability into an intellectual strength, right? That is what a person should be like, right? He is an Indian. I am proud to be an Indian. I am proud to be an Indian. Jai Hind. Okay, let's see. Let's see the next question. A power m, b power n, such that m equal to 2n plus 1. So we have done this model actually. We have done this model in push down automata. If you remember, I have done this a power n b power 2n plus 1. We have done this same model, right? Therefore, this is deterministic context free language. This is definitely not regular. This is context free language also. This is context free language also, right? Right? We have done this model. For every a you push two a's, and for every b you pop one a, and now finally one b should remain. One b should remain, right? Right? We have done this model earlier. We have done this model earlier. We have done this model earlier. Okay. We have done this model earlier. We have done this model earlier. Okay. Okay. Now we will do one more question. A power n square such that n is greater than or equal to 1. This is a non-linear power. A power n square such that n is greater than or equal to 1. You try it first. You try it, write the answer in the comment. A power n square such that n is greater than or equal to 1. You write it in the comment. Okay. Okay. So this is definitely non-linear. This is definitely non-linear. This is definitely non-linear. This is definitely non-linear. This is definitely non-linear, right? 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 This is definitely non-linear, isn't it? This is definitely non-linear. So this is not regular for sure, and DCFL also cannot do anything, and CFL also cannot do anything, and this is CSL. This is CSL. Okay. We will see one more problem. We will see one more problem. So we'll see this question. A power n square is done. A power 2 power n such that n is greater than or equal to 1. This is exponential power. 2 power n means exponential power. So definitely regular language cannot do, DCFL cannot do, CFL cannot do, CFL cannot do, but CSL can do, but CSL can do, but CSL can do, right? 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 But CSL can do. Now let's see a power n factorial. A power n factorial such that n is greater than or equal to 1. This is also non-linear power, right? So we know that regular languages cannot do. We know that regular languages cannot do. We know that DCFL cannot do it. We know that CFL cannot do it, but CSL can do it. CSL can do it. CSL can do it, right? Now similarly, if I write a power m such that m is prime, a power m such that m is prime, a power m such that m is prime, right? Right? So definitely regular languages cannot find out whether a number is prime, and CFLs cannot find out. Therefore, this is CSL. I'll tell you later why it is CSL. Okay? 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 Let's do one more question. Let's do one more question. A power k such that k is even. 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 Okay? So this language is definitely regular. We have seen this. A power k is even means a star. A star is the language which is a regular expression. Therefore, this language is definitely regular. This language is definitely regular. Okay. Let's see one more problem. Let us see one more problem. A power I, B power j, C power k such that I comma j comma k greater than or equal to 0. Such that I comma j comma k greater than or equal to 0. Such that I comma j comma k greater than or equal to 0. Think about it. Take time. Don't be in a hurry. Write the answer in the comments. Write the answer in the comments. Write the answer in the comments. I, j, k can be any number greater than or equal to 0. So what will happen here? This will be A star, B star, C star. This is a regular expression. So clearly this is regular. Clearly this is regular, right? Now if I write like this, A power I, B power j, C power k, such that I is greater than k, I is greater than j, and I comma j comma k greater than or equal to 1, or you can also say greater than or equal to 0. Anything is fine, right? So A's and B's have to be compared. We don't have to compare C's. So definitely this can be, you do it. Instead of me directly giving you the answer, I'll give you time, you find out, okay? I'll give you time, you do it. I'll give you time, you do it, okay? I'll give you time, you do it. I'll give you time, you do it. So, A's and B's can be compared by deterministic push-down automata, isn't it? And C's need not be compared with anything. Therefore, this is deterministic context-free language. And obviously, this is not regular. This is sure. This is not regular. And this is CFL. This is CFL. And this is CSL also, right? Right? Now, if I just extend this question a bit, and if I write like this, A power I, B power j, C power k, such that I is greater than j is greater than k. I is greater than j is greater than k. A power I, B power j, C power k, such that I is greater than j is greater than k. I is greater than j is greater than k. I is greater than j is greater than k. I is greater than j is greater than k. Here we need three comparisons, right? Here A has to be compared with B and B has to be compared with C simultaneously, which means both these comparisons should happen at a time. A has to be compared with B and B has to be compared with C. Once you compare A's with B's, A's and B's will be over. There will be nothing to compare with C's. Therefore, a deterministic context-free language cannot do it, and a context-free language also cannot do it, but CSL can do it, right? And definitely this is not regular. This is for sure that this is definitely not regular. This is definitely not regular, okay? So we will see the next question. We will see the next question, right? The next question is A power I, B power j, C power k. Shall we do a story? You must be boring. It must be boring for you. We will see a story, okay? We will see a story and we'll come back. Riddhima Pal, IIT Kanpur, BS in Mathematics and Scientific Computing. Background, born with spinal muscular atrophy, which means SMA, wheelchair bound. She cannot walk from childhood. Faced school denial. Schools have refused to join her. And education, she joined IIT Kanpur after a preparatory year at IIT Indore. Career, she scored exceptionally well in class 10 and class 12 and qualified for IIT despite missing the direct rank by 1 mark. Despite missing the direct rank by 1 mark. A living example of academic excellence and resilience over overcoming physical challenges and social bias. ठीक है? She is an Indian. I am proud of her. She is my hero. She should be your hero. ठीक है? Jai Hind. Okay. So let's now see the next problem. Let's now see the next problem. Let's now see the next problem. A power I, B power J, C power K such that J equal to I plus K, such that J equal to I plus K, J equal to I plus K, J equal to I plus K. A power I, B power J, C power K such that J equal to I plus K, J equal to I plus K. How are you going to do this? Take time, think about it. Think about it. Don't be in a hurry. Take your time, think about it, and tell me the answer. Okay? Take your time, think, and tell me the answer. Okay? A power I, B power J, C power K such that J equal to I plus K. J equal to I plus K. So in place of J, you are going to write I plus K. Okay? So A power I, B power I plus K, C power K. Right? So what do you get then? A power I, B power I, C power K, sorry, B power K, C power K. Right? Right. Now for every A you are going to push an A. For every B you are going to pop a B, pop a A. For every B you are going to pop a pop a B. For every A we are going to push a. For every A we are going to push a. And for every B we are going to pop a. And once all the A's are over, then you start pushing B. And once for every C you are going to pop a B. That is how you are going to do this, right? That is how you are going to do this. That is how you are going to do this, right? 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 Is it okay? Is it fine? Okay. Now let's do one more question. Let's do one more question. A power I, B power J, C power K, C power K, D power L such that I equal to K, I equal to K or J equal to L. I equal to K or J equal to L. I equal to K or J equal to L. I equal to K or J equal to L. I equal to K or J equal to L, which means these two have to be equal and these two have to be equal. I equal to J, these two, A power I, C power K, these two have to be equal, or B power I, D power J, D power L, these two have to be equal. These two have to be equal. Right? 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 So in NPDA can do that. In NPDA, it will go in two directions. In one direction, it will compare A's with C's, and in other direction, it will compare B's with D's. Either here we reach a final state or here we reach a final state, we are going to accept it because it is or is given, right? Now just imagine what if and is given, which means A should be compared with C's as well as B should be compared with D's, and we have to do it simultaneously. So this cannot be done by a push down automata. Push down automata cannot compare A's with C's because B's will be in the middle, and push down automata cannot compare B's with C's, D's because C will be in the middle, right? 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 So if it is R, it is CFL. If it is R, it is CFL because NPDA can accept it. If it is AND, NPDA cannot do this. NPDA also cannot do this. So this is not context free language. This is context sensitive language. or means it is context free, and means it is not context free. Okay, okay, try to remember that. Try. Now we will see one more property, one more question. Okay, so the question is so the question is a power m, b power l, c power k, d power n such that m comma l comma n comma m comma l comma n comma k greater than or equal to 1. M comma n comma l comma k greater than or equal to 1. M comma n comma l comma k greater than or equal to 1. Think about it. M, L, K, N all are unrelated and all of them are greater than or equal to 1. So what is this language? This language will form A plus, B plus, C plus, D plus, right? So which is a regular language. A plus, B plus, C plus, D plus is a regular language. A plus, B plus, D, C plus, D plus is a regular language, right? 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 A plus, B plus, C plus, D plus is a regular language, right? So this is regular language. Now, if I give you A power n, B power 4m such that n is greater than or equal to 1, n comma m, n comma m greater than or equal to 1, n comma m greater than or equal to 1, or let us say n comma m greater than or equal to 0. A power n, B power 4m such that n comma m greater than or equal to 0, such that n comma m greater than or equal to 0. A power n, B power 4m such that n comma m greater than or equal to 0. Okay. How are you going to write this? This you can write it as A star followed by B B B B star. A star followed by B B B B star. A star followed by B B B B star. Right, right. And this language is clearly regular. This language is clearly regular. What if I change it a little bit and if I write it as A power n, B power 4m such that n comma m greater than or equal to 1. A power n, B power 4m such that n comma m greater than or equal to 1. If I modify a bit, I have not modified it. A power n, B power 4n such that m comma n greater than or equal to 1. M comma n is greater than or equal to 1. What can you say about this language? What can you say about this language? Take time. Take time. So, A's have to be compared with B's and B's have to be 4 times that of A's. So, for every A you push 4 A's and for every B you pop 1 A. So clearly this can be done by deterministic push down automata. Therefore clearly this is DCFL. Clearly this is DCFL. This is not regular. This is not regular. This is clearly DCFL. Right? Right? This is clearly DCFL. Clearly this is DCFL. Right? Right? Now let me give you one more question. Let me give you one more question. A power 3, A power 8, A power 13, A power 18, so on. A power 3, A power 8, A power 13, A power 18, so on. So on. What is this language? What is this language? This is in arithmetic progression and the common difference is 5, isn't it? From 3 to 8, 5, 8 to 13, 5, 13 to 18, 5. This is a AP. This is in AP and the common difference is this is in AP and the common difference is 5. This is in AP and the common difference is 5. This is in AP and the common difference is 5. Right, right. So how are you going to solve this? So you can write it as actually A followed by A whole star. Matlab, you will get A power 3, A power 8, A power 13, A power 18, so on, right? So this is a regular language, isn't it? This is a regular language because we are able to give regular expression. This is a regular language, right? Now tell me about this. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. A power 2n plus 1 such that n is greater than or equal to 1. You know that this is nothing but odd number of a's, isn't it? This is nothing but odd number of a's, right? And we know that odd number of a's is regular. We know that odd number of a's is regular. Answer me this question. A power n power n, A power n such that n is greater than or equal to 1. A power n such that n is greater than or equal to 1. This is clearly non-linear, right? So this is clearly non-linear. This is clearly non-linear. This is clearly non-linear. This is clearly non-linear. A power n is clearly non-linear power, right? Clearly non-linear power. This is clearly non-linear power. Therefore, this is definitely not regular. This is definitely not context-free language, non-linear power. This is definitely CSL. This is CSL. We will see later how it is CSL. Okay. We will see later how it is CSL. Okay. 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 Let's do one more problem. So the problem is a simple one. You should be able to do this. A simple problem, you should be able to do this, right? Right? W such that W belong to A comma B star, W such that W belong to A comma B star, and mod W is greater than or equal to 100, and mod W is greater than or equal to 100. Okay, what is this language? W such that W belong to A comma B star, and mod W is greater than or equal to 100. Mod W is greater than or equal to 100. Mod W is greater than or equal to 100, right? So what is this language? This language is nothing but string length is at least string length is at least 100. The language is nothing but string length is at least 100, right? And we know that already this is regular. This is clearly regular. This is clearly regular, right? Right? Now let us see one more problem. Let us see one more problem. So the problem is L equal to set of all strings W such that number of A's in W is equal to number of B's in W. Number of A's and number of B's should be equal, and sigma equal to A comma B. Set of all strings over A comma B such that number of A's in W is equal to number of B's in W. Number of A's in W is equal to number of B's in W. Number of A's in W is equal to number of B's in W. For this question, we have already done push down automata, isn't it? We have already done a push down automata, and that too a deterministic push down automata, right? Therefore, this is deterministic context free language, and definitely this is not regular. Regular languages cannot compare A's and B's, right? Definitely this is not regular, but this is DCFL, and so this is a DPDA, and so DCFL, okay? And so DCFL, right? Now let us see one more problem. Language equal to set of all strings W such that number of A's in W is equal to number of B's in W is equal to number of C's in W, right? Sigma equal to A comma B comma C. Sigma equal to A comma B comma C. Sigma equal to A comma B comma C. Number of A's in W is equal to number of B's in W is equal to number of C's in W. Number of A's in W is equal to number of B's in W is equal to number of C's in W. Right. You can compare A's with B's, or you can compare A's with C's, but the problem is once A's and B's are compared, A and B will vanish. There will be nothing to compare with C, right? So comparing all these three is very difficult using context-free languages, using a push-down automata. So a push-down automata cannot do it. Push-down automata cannot do two comparisons at a time. Here there is two comparisons, right? One comparison, one more comparison. Push-down automata cannot do two comparisons at a time. Push-down automata cannot do two comparisons at a time. Push-down automata cannot do two comparisons at a time. Push-down automata cannot do two comparisons at a time. Push-down automata cannot do two comparisons at a time. Isn't it? Therefore, this is not context-free language, but this is context-sensitive language for sure. I'll show you later, okay? Now, if I just change the language a bit, and if I write like this, L equal to W such that number of A's in W is equal to number of B's in W, or number of A's in W is equal to number of C's in W if I write like this, there is comparison, but one comparison at a time. Both the comparisons need not be done, right? You try to do it. You tell me what is the answer, write in the comments. You tell me what is the answer, write in the comments. So now if you observe it, A's have to be compared with B's or A's have to be compared with C's. Therefore, we can go in two directions. We can go in two directions. One direction is A's is going to be compared with B's, and other direction is A's is going to be compared with C's. A's is going to be compared with B's, and the other one is A's is going to be compared with C's. A's is going to be compared with C's. S is going to be compared with C's. Therefore, a non-deterministic pushdown automata can accept it. Therefore, you can say that the language is context-free language, but the language is not deterministic context-free language. It is not deterministic context-free language, but this is context-free language. But this is context-free language. But this is context-free language. Right? 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 Now, I will change the question a little bit. Let us see this question. L equal to set of all strings W such that number of A's in W is equal to number of B's in W plus 1, which means one extra B has to be remained. It is very easy, right? And sigma equal to A comma B. Sigma equal to A comma B. Sigma equal to A comma B. L equal to W such that number of A's in W is equal to number of B's in W plus 1, sigma equal to A comma B. So number of A's should be more than number of B's plus 1. Number of A's should be more than number of B's plus 1. Number of A's in W should be equal to number of B's in W plus 1 plus 1. Number of A's in W is equal to number of B's in W plus 1. Okay. So what happens? You are going to compare A's and B's. Finally, if one extra B remain, finally if one extra A remain, number of A's equal to number of B's plus 1, right? Finally, if extra A remains, then we can say that number of A's equal to number of B's plus 1. This can be easily done by deterministic pushdown automata. This can be easily done by deterministic pushdown automata, right? So this language is deterministic context-free language. So the language is deterministic context-free language. Deterministic context-free language. Okay. Okay. So we have solved a lot of questions on this. But one thing I didn't tell you is what is the definition of a pushdown automata. We will see the definition of pushdown automata now. We will see definition. So till now we have seen many questions on PDA. But I didn't give you the definition of PDA so far. Okay. The reason is if I give you definition of PDA initially, you will not be able to understand it. That is why at the end of the topic, I am giving the definition of PDA. So let's see the PDA definition. Okay, let's see the PDA definition. Let's see the PDA definition, right? So PDA definition is Q sigma delta Q naught Z naught F and tau, F and tau, right? So you know most of them already from regular languages, DFA and NFA, right? What is Q? Q is finite set of states. Q is finite set of states. Q is finite set of states. What is sigma? Sigma is input alphabet. Sigma is input alphabet. What is delta? Delta is transition function. Delta is transition function. And Q naught is initial state. Q naught is initial state. And F is set of final states. F is set of final states. Okay. And tau is stack alphabet. Tau is stack alphabet. Means what are the symbols that we are moving in tau, right? Into the stack. Right. Now we know that push down automata is of two types. Push down automata is of two types. One is deterministic push down automata. Deterministic push down automata, and the other one is non-deterministic push down automata. Non-deterministic push down automata, right? And deterministic push down automata is given a stack, given a state. If I am in a state and if I see epsilon union sigma, and if I see some symbol on the top of the stack, I will go to exactly one state and I will print something on the stack. Okay. Coming to non-deterministic push down automata. Delta Q cross sigma union epsilon cross tau. This gives us, we can go to any number of states 2 power q, and then we can print anything on the top of the stack, right? So this is exactly same as DFA and NFA, right? One thing that you have to understand here is, when coming to DFA and NFA, both are same in power. Coming to DFA and NFA, both are same in power. DFA and NFA are both are same in power. But coming to push down automata, deterministic push down automata is less in power compared to non-deterministic push down automata. Deterministic push down automata is less in power compared to non-deterministic push down automata. Right? Okay. So we will end it with a story. We will end the lecture now. We will end it with a story, an inspiring story. Peter Norman, the white man who stood still. Background: Australian sprinter at 1968 Mexico Olympics, a time when civil rights tensions were boiling, chose to silently stand with black athletes Tommy Smith and John Carlos during their iconic Black Power salute, wore the same badge, Though he won the silver, he was abstained by Australia, left out of future Olympics, and forgotten for decades. He never raised his fist. He just stood still with conviction. If he could hold his ground just under the global pressure, you can hold your line under exam stress. Right? Right? So, guys, Jai Hind, Vande Mataram.